Good afternoon, everyone. My name is Ikechukwu Ogbuchi. I'm a master's degree student here at ATU, and I'm studying computing. My supervisors are Dr. Ethan Kelly from the School of Science and Computing, Dr. Cormac Wigley, and Donald McGinty, who is the IT manager here at ATU. First, I would like to thank the organizers of this conference for giving me the opportunity to speak here and talk about this project. This project on the application of machine learning to optimize student engagement levels has been made possible due to the work of a lot of people who you can see on the slides. And these people have been working on this project since 2015. I only joined this project last year to contribute some of my skills in data analysis to the project, which is currently ongoing. And these people include my supervisors, Garrett, Mark, Fiona, Elaine, and lots of other people on the background who are making this project possible. To begin with, I would like you all to imagine a university where every student feels like they're actually being cared about. And they're not just cared about based on how they are performing in classes or their finances, whether they are paying their school fees or not, but a university that makes students feel like they're actually a part of what is happening in the school, and that the university cares about them and cares about what they are going through. And that is the motivation behind the project which we are doing on the application of machine learning to optimize student engagement. Now, like I mentioned, the project has been in development since 2015. We have previously been using data analysis expressions to identify students who could be at risk based on how they are engaging on their learner platforms. There were limitations with the previous methods which we have been using, and those limitations include the use of formulas, Excel formulas or data analysis expressions to identify students who could be at risk. But we are beginning to explore the use of machine learning to be able to find patterns in the vast amounts of data which has been collected previously, and this is helping us to be able to see patterns in the way the students are engaging with their learner platforms. And part of our goals on this research is to refine the work which has been done earlier, and also to see the power of machine learning models and also see how they can help us to better understand our students. Now, student engagement as regards the context of this project refers to how the students are interacting and participating with their learning activities and courses. And there are three major kinds which we are looking at, and they include the behavioral engagement, which involves how the students act and how they interact with their courses. The cognitive engagement, which involves how the students are mentally taking on the tasks which they are assigned, and also how the students are thinking through the tasks which they have. And then the affective engagement, which takes into consideration how the students actually feel about the courses that they are doing. And we are looking at various analytical methods, which include the descriptive, the diagnostic, the predictive, and the prescriptive methods in order to understand what is going on in the data which we are analyzing for the students. The online platform which we are getting our data for this project is the Moodle online learning platform, which is where students get to interact with courses created by their lecturers. They get to write their assessments, check their grades, participate in quizzes, and take on other resources. And we are beginning to find some very interesting patterns in the data from the log files, which we also get on the Moodle platform. There are 6 key steps which we are taking in this project. The first one is defining the objective, which is to better understand our students and also to be able to predict changes in patterns as regards how our students are interacting. The second step is collecting data from various sources, but the primary source for now is the Moodle learning platform. We can also collect data from Microsoft Teams and other learning platforms which our students engage in. And the third step would be to clean the data which we are collecting from these platforms in order to put them in the right structure for analysis. And that involves use of programming tools like Python programming, spreadsheets, Excel, and some other software tools to help us to put the data in the right structure for the analysis which we are doing as regards this project. And the fourth step is where we run our data analysis and apply some machine learning algorithms on the data which we have to be able to find patterns that are not easy to identify by humans. And then we visualize these results using Power BI software, and we share our findings and results with the stakeholders, teachers, and lecturers. And this is what the previous dashboard looked like, which is just showing, these are fictitious names, these are not actual student names. This dashboard shows the students who could be at risk based on a set of formulas which has been embedded onto the spreadsheet, and it also highlights these students who could be at risk using color syntaxing. And it also shows us that by the department. So this is what the previous dashboard looked like. And then I'll talk about the descriptive and diagnostic analysis, which we are currently doing here at ATU, which involves analyzing how the students are interacting during the day, during the month, the patterns we can find in the student engagement, and also how we are finding out what is happening in the data. So the slide which you can see now refers to two student groups, which we are currently using as our first set of students to analyze. They include the science students and the computing students. And we looked at last year's data for the science students, last year's data for the computing students, and we are looking at the current data for both the science and the computing students as well. So you can see on the left-hand side, this is a chart showing the level of Moodle interactions and the grades for each of the students. And the pattern which you can see across all of the four modules which we selected is that there seems to be a positive correlation between how the students are engaging with their learner platform and the grades which they are getting. So this gives us reason to believe that there is a lot of potential in enabling students to engage more with the platform as this leads to significantly better grades. On the next slide, we broke down these interactions by the month, and we have seen a common pattern across all of the modules. For the science students, the last year science students, they all seem to interact the most during the beginning of the semester in October. This drops down in November, drops further in December, and then due to the festive period, there's a drop in January, but they never seem to go as high as the previous semester. And this is happening across even the computing students as well. So these are some of the things that we are picking up from looking at the data, and it's helping us to think around why we are experiencing the lower interactions at the second part of the semester, and we are still finding out the why behind some of the patterns that we are seeing. And then we also broke down these interactions by the day. So these are the same interactions previously, but the daily interactions. And we're also seeing a similar pattern, just like the monthly interactions. They seem to engage more at the first semester, but then after the break for the second semester, the interactions seem to drop across all of the modules. And then we also looked at the interactions by the day of the week. The science students seem to interact more on Thursdays, followed by Wednesdays, while the computing students seem to prefer Mondays. And we are also seeing that some of the students are interacting very well with the platform during the weekends as well, which seems unlikely. And then that leads me to the predictive and prescriptive approach, which we are currently looking at. And this is where we try and apply the machine learning technology to be able to explore patterns in the data and be able to predict what a student might do in future based on how they're interacting with their learning platforms. This is also where we use student surveys and feedback to get how the students feel about what we are doing and how students are a part of the development of what we are currently doing. And so that leads me to why machine learning. So I won't go into the nitty-gritty of how machine learning works, but machine learning is just a fancy word for saying that a computer should look at large amounts of data and find patterns in that data. And the benefit of this machine learning technology over what has been done previously is that this technology is able to find patterns that are not very easy for humans to find because there are loads and loads of data. But the way it works is that you train the computer to find patterns based on what you currently have, and then the computer learns how to find those patterns on its own without you necessarily having to program it all the time, which was the limitation which we had previously. So the two types of machine learning are the supervised and the unsupervised learning. The difference between the two of them is simply that for the supervised learning, you tell the computer what you are looking to find. But in the unsupervised learning, you just put in the data and the computer is able to just show you the patterns that it can find from the data. So on this slide, we can see some of the snippets of the codes, the Python programming codes, which we use to run some of our machine learning models on the data which we are extracting from the Moodle learning platform. And you can see that there are some clusters which is identifying. The clusters refer to the distinct group of students that the model is able to find. From the analysis that we've done, we are seeing that the K-means model is the best model that performs better than the rest of them when compared to the Bayesian model and the Gaussian model in terms of analyzing and finding patterns in the data. And as early as the 5th week, we're able to use this predictive analysis to identify students who could be at risk based on how they are interacting with their platform and how they are engaging. So this is a 3D plot of the student groups which the machine learning model was able to identify. And you can see that this is across the journals, the grades, and the quizzes. And there are 3 different clusters which we have been able to identify. The clusters at the top right, the ones in red, are the ones that are performing well and they are engaging well. The ones around the middle, which seemed a bit scattered around, are the ones that are in between. You know, they could go either way, but they are a group of students as well. And then the ones at the bottom left-hand side are the students who seem to be struggling with the course. So these are the kind of patterns that machine learning technology helps us to identify from the data which we have from Moodle. So this is what the current dashboard looks like right now. We are able to see at a glance the students who are not at risk, the students who are likely to be at risk, and the ones that are flagged as being at risk based on the predictive capacity of the machine learning model that we have. And then we are able to see at a glance all of the interactions by the date. We're able to see the interactions and the average grade by each student, and we're also able to see the various components that the student interacts with. This video here shows that we can also drill that down to a single student as well. So we're not just looking at the interactions as a whole, we are also able to see at a glance how each student is interacting, where they stopped interacting, and this helps us to derive insights as regards why a student might have stopped interacting with Moodle at any point in time. So the next thing we are doing is for the student participation and feedback. So we are not just developing these solutions without involving the students. We are ensuring that the students are active participants in what we are creating for them. So what we do is that we discuss with the students regarding what we are doing with the data, how we are analyzing their data, the software tools that we are using, and we also send surveys to the students to get how they really feel about what we are doing for them. And so far, we've been getting very good reports from the students. They say they appreciate what we are doing. They feel like, just like the comment that Colin made and Meg also made about the mental health, and what Colin said about a student saying that they feel they are not just considered as being a numeric, that they feel it's more personalized to them. So we see that this student participation in what we are doing is really, really important. And we can see that most of them, a total of about 96%, agree that what we are doing is useful. So the next steps for this project would be to refine what we are currently doing with all of the people working on this project across the team to make our model more explainable, to ensure that we create programs that are tailored to each of the student groups. And we're also looking to scale what we are doing, not just for the science and computing students, but across all of the students in the university. Thank you very much.